Hi guys, I'm Erin Lee from Korea International School and I'm part of the We Learn to Share team. And today I'm going to teach you guys geometry, which is a typical course took by 9th graders or 8th graders. So the first unit that I'm going to teach you guys is the circle theorems, and it just addresses all the theorems and rules related to the circle. So let's dig in right away. So the first theorem that I'm going to teach you guys is called the central angle theorem, often abbreviated as the CAT. First, let's label the points. Point A, point B, and the center O, right? And we're going to call this angle AOB, but this is a central angle. That is because this angle is created between two radiuses. And this, we're going to call it arc AB. So what kind of relationship does arc AB and angle AOB have? In this situation, and the arc AOB has the same measure. Arc AB has the same measure as angle AOB. Sorry, my mistake. So this applies to any angle, central angle of the circle. It can be this size, but this might vary between like who your teacher is. My teacher told me that the central angle should be a minor arc, which is smaller than 180 degrees. But in most cases, they won't really specify these rules, and these will probably work. The next is IAT, inscribed angle theorem. So let's label the points as usual. So angle ABC, this is an inscribed angle. And this is, as you guys know, arc AC. This is a symbol for arcs. So they also have a special relationship. Angle ABC has half the measure of arc AC. This is what you guys need to really remember. It's a really important concept. And next, let's go right away to the next step. So we need to know what a tangent is. So tangent is a line that intersects with the circumference of a circle only once. So that point that the tangent meets is here. So a radius that has its point on the intersection between the circumference and the tangent has a perpendicular relationship with the tangent itself. So this is radius AO, tangent so both of these angles are 90 degrees, right angles. And the next theorem is called the tangent chord theorem. A chord is a segment that has two ends on the circumference of a circle. So this let's label the points. And we will call this arc BA. And yeah. So this angle is angle ABC, right? Arc BA has the twice measure of angle ABC. So let's some of the most basic questions contains this concept is just like this. So like you have a circle and you have a circle and a tangent here, right? And there is a chord right here. And this question clearly states that this is a tangent, and that this is a chord. It tells you that this angle, so like as a measure of 55 degrees. And then it asks you arc A. Then you will need to use the tangent chord theorem and think that BA has twice the measurement of arc angle ABC. Then substitute this with 55 degrees. That will give you 110 degrees, right? And the next theorem is the circumscribed angle theorem. So this is a circumscribed angle. So it's an angle created by two tangents. Then the special relationship here is going to be angle ACB here and angle AOB here. Added up will create 180 degrees. And congruent Chords theorem. This also needs a very special condition. This is chord AB, and this is chord CD, and we will be given that chord AB congruent to chord CD, which means that they have the same length. And this is going to lead us to the conclusion that arc CA is congruent to arc BD. And the parallel chords theorem. This is our chord AB, chord CD, and we will be given that they are parallel. Then, oh no, sorry. I confused it a little bit up. Let me address this issue. So the congruent chord theorem, this is chord AB, this is chord CD. Will be given that AB, CD, which means that they have the same length. And this will tell us that arc AB is congruent to arc DC. And the next theorem is the parallel course theorem. And we are given that chord AB is parallel to chord CD, which can lead us to the conclusion that arc AC is congruent, CA is congruent to arc BD. Tangent, angle theorem. So we first need to label all the points, right? And this theorem tells us that angle ABC is half the measure of arc CA subtracted, arc AC subtracted by arc CA. So if we say that CA measure of, I don't know, like 300, and next is secant tangent angle theorem. This tells you that angle BCD is half of arc BD subtracted from arc DA. And the next is secant tangent segment theorem. And this is different from the angle theorem as it addresses the nature of the segment, not the angle. We say these are the points that we need. And we're gonna say CD squared is equal to AC multiplied by BC. That's the rule. So for example, if we're given that this is 4 and given that this is 8, no, right? Therefore BC is 2. And the secant angle theorem is really similar to the two other angle theorems that we just saw. Angle BCD is half of arc BD subtracted by arc EA. The next is the secant segment theorem. Say that this is A and this is B, this is C, and this is D. Then we will learn that B multiplied by A equals D multiplied by C. That's the rule. And the next is intersecting chords segment theorem. If we just put this, we can come to the conclusion that A multiplied by B equals to C multiplied by D. And this states if this is angle X and angle X is half of the sum of arc AB and arc DC. And the last theorem that I'm going to explain to you guys is when there is a it's the cyclic quadrilateral theorem. And this is when a quadrilateral has all 4 points on the circumference of a circle. And then the angles that are facing each other has a sum of 180 degrees. So like this. So this is all I have prepared for today's video. And for the next video, I'm going to bring some circle theorem practice problems for you guys to solve. And I'm going to go through step by step with you. So thank you for watching, and I hope you guys enjoyed. And please, if you like the video, please put subscribe, like, and comment if you have any questions. Thank you. It was Erin.